So thanks for everyone. I'll be quick because the main goal was to be out at 12:30, and just to show we are just a few in the group, and what we build at the core is a library. So that's so what I present now. It's just very much hands-on code. So it's nothing to do with, it's not the science, but to show you a tool that you may use to make science if you want to use this one, but that's the one we're developing in this group. And so that's with Roberta, Ronan, they're all contributors to the GitHub project because it's open source code, like ForeFire could be, but it's just somewhere else. It's not, just to give you an idea, so installing, it's just going to the website and cloning and doing the stuff, and you should get running into about 10 seconds. You can actually open, so you build a Docker image, and then what you have is an interpreter. So the ForeFire code, just to explain, it's actually an interpreter. So it's a event-driven language to execute whatever code you want to build, especially designed for rate of spread models, but you could spread a lava model as long as you have a velocity model. You code it into it, and now that what you have is a web interface on top of it. In fact, you have more than a web interface. You have a HTTP service that you can run and that will interact with the simulation while it's running. So you can build your whatever interface you want on top of it to have actually a local version that is running like a desktop version. And you could export that to a web version afterwards. And the desktop version is this one. So when you have a process of ForeFire, that means that you could also launch a web service inside it. So the socket is inside the code, and you have it. To couple it with MesoNH, the bindings are already there. So MesoNH, when you compile it, you have it, like WRF. It's like a plugin. So as you compile it, it's a shared library. You drop the shared library into the folder of MesoNH, and magic, you have you can have coupled model. And basically, and to compile it is using CMake. So that is very. And without that, it's already used by our friends at Valab. There's been we've designed it as a scripting tool, so we can try different scenario and do it multiple doing things. But they also use it with Aurora Tech. I don't know if they are here. No, they there? No? Yeah, Dominic. There. We've been working. At some point, you used it for the wildfire spread solutions, and the friends. And basically, that it's like at this point, it's a service. That means your data is already pre-computed, and you run the simulation, or you couple the simulation in the system. That is was the same trend for last time here and so on. So just to give you an idea, so that's a basic simulation. So you build a script and you have different things. So you set the resolution like that, you're loading data, and you're adding, and then you have a run script, and you run it, you launch the interpreter, you include the script, or you can open it, and then you all right. If you print, then it prints out at the format if you want something that you can include back, that will be the shape of the thing, and eventually that's how it works. And then you can launch listen HTTP on whichever socket you have if you need to have a web interface. And that's going to be the web interface. That's the default one. You can build your own. So that represents all the fields. And it's just cool because it's kind of agile, because then you can try, test, error, and you have the simulation running, and you set a parameter, and you run on. Well, what Alberto showed is it works also in a coupled mode. So simulation was running on 200 processors. But you can change the parameter of spotting ignition, and then the simulation changes. so that you can try. It's just to make it more easy for people to try different things. So what is a fire case? The fire case is just basically it's initialization file if you want and parameters files. That is going to be what is in Meso-NH. And then you got some operators to postpone things. Because it's event-based, that means that there's no continuous action, there's no simulation start and simulation end. It's a continuous time, and you get events, so you can trigger stuff at some time, or you can trigger an action at some time, or you can trigger a relative or next time, and it could be included into a script. So that makes it very versatile to do whatever you want. In the standard trunk, you got two idealized cases. If you want to try it out, one is you use an orography, and you use an idealized case. So there's some tools to make your own weather profile, and that's gonna give out some weather profile for the coupled model. And the case is actually this one, but at a lower resolution. So it's where I had an absurd amount of cape and to generate a velocity of the fire front that was ×2 the parameter. So I could generate some fire-induced vortices that were and fire tornadoes like that. And basically, typical case, you have a fire resolution that is about 10 meters. To compute the flux, the arrival time map. And then the atmosphere resolution is about 80 meters. So, and that is, so it's just to have fire-induced vortices, it's better if you have a specific canyon configuration to start to induce these things. And what you see here is water content. And what you see here is the fire nado thing. That could be solved by Meso-NH. So yeah. There's a simplified case also for spotting. So that is an ensemble of 4 with the same parameterization. So you can try the spotting straight on. At least it should be now, or not, yes? So that so if you want to play out to compare what is the effect of convection on the overall and try to start yourself some of your spotting parameterization. And also this one I showed it too much, but I like it a lot, and because it's I did it with my friends from Evra that very unfortunately cannot be here, and for some reasons, and that's the Pedro Grau Grande, and that is a standard case as well for the test. And what you see here is the interaction of that's a big downdraft, and that is water vapor, and ice on the top, and that's the beauty of Meso-NH, and that's the ability of catching up like pyroconvection, how it speeded up winds, how it makes fire acceleration, and the interaction especially with a whole pyroconvective event that just lasted about 1 hour, but changed dramatically the dynamics of the propagation. But then that means that yeah. So that's the test case in the standard thing. Just to show you, test case that is this one. So this is running. This is not running because of internet. I didn't know. So it's a video of the same thing of Pedro Grau running on this computer. And so when you run it on the supercomputer or this one on multiple processor, then you can copy paste the HTTP address, and then you open it like that on your local host. You're opening on the same machine, and then you eventually have the map. So that means that runtime, you have a coupled fire atmosphere running on your laptop, and you can even you have access to the different fields, and you can even click to start new fires on your laptop. It's running coupled fire atmosphere things. So just the fact that it's event driven and thing takes this kind of level of interaction. just to play with. So you can even try your new rate of spread model using that. And even have, so we built in, since the last version, a class, so we don't need to link with TensorFlow, C, or whatever. So we have a small class to use any graph that you will have trained, simple graph. I mean, there's only 4 activation functions, but you could put whatever graph you have, and it's in binary, and it will read it, and you can use it anywhere in the code. So that means that we can train a spot recognition model, and then we will use it during the simulation, because you can call it from anywhere in the code, because we have a header for that. But we don't have any scientists that want to do it with the code right now. So, and adding model is just a template, so it could be a rate of spread model using a train graph too. And and to train the neural networks rate of spread model, we developed this with this library too, which is open source, and so we emulated. But Roberta is going to speak about it tomorrow, right? But later, not today, tomorrow. No, I think this afternoon. Yes, and voila. That's it. So I take any questions. Thanks a lot.